Hi everybody, so my name is Léa and I'll present my research on embodied carbon for interior architecture today. So this research was completed over 9 months with MTU as part of a master's while working with Mahon Architects, and the goal was to understand what the impact of interior equipment, or FF&E, is on the carbon footprint of a building. I was looking in relation to its life expectancy rather than just the construction stage. So how can architects calculate this, and how can we help them by making it easier with a Revit workflow, for example? So just a brief overview of my presentation. I'll quickly give a reminder on embodied carbon, explain my proposed workflow using Revit and EPDs, how I tested the workflow in an exemplar project, my results and interpretations, and the conclusions. So just a brief reminder on embodied carbon of a building or a product. It's the CO2 and greenhouse gas emissions that are generated during its entire life cycle. So it's divided into stage and modules, so anything from collecting the raw materials to the manufacture, the construction, the use and the end of life. The best way to reduce the embodied carbon of a project is by thinking about it from the very early stages, which is what I tried to do in relation to FF&E in architecture. Sorry, there's a picture missing there. I'm not sure why. It's not. Oh, there we go. So this is just looking at LCA calculations. We typically use 60 years during our calculations. The tools that are available to architects to calculate LCAs, like one-click LCA in this example, typically don't include FF&E, although they might include floor finishes and ceiling finishes. However, research has shown that interiors can be refurbished anything from 2 to 15 years on average. For example, restaurants or shops might have a high level of refurbishments. So as we can imagine, at the end of construction, the carbon footprint of the structure and envelope will be very high in comparison to FF&E because we just built the structure from scratch. But what about 60 years later if we take into account those refurbishments? So in some cases, after 60 years, it's possible that the embodied carbon that's generated by the FF&E will be as high or even higher than the buildings because of those refurbishments. So you can see here on this diagram, in blue and in green is the structure and envelope, which is represented at year 0, so construction, the end of construction rather, and the embodied carbon there is very high in comparison to the interiors in purple. But when you look at 60 years, with all those refurbishments, the cumulative impact of the FF&E is actually very important. In this diagram, it's even higher than the structure and envelope. In this diagram, it shows the difference between the first 10 years of the use of a building and 60 years. So when you look at 10 years, the base building, which is the structure and envelope, has very high embodied carbon, over 3/4 of it, whereas interiors in yellow only represent a small portion. And that's because over 10 years, your structure and envelope was just completed and there hasn't been any refurbishments yet. But when you look over 60 years and you account for those refurbishments, the interiors in yellow actually take over half of the embodied carbon that's generated during that period. So one of the ways we can assess a product's carbon footprint, such as FF&E, is by using the environmental product declarations. So those are documents that are created by a supplier, and they assess the carbon footprint of the item. They assess it for 1 unit of product. There are many different emissions that are looked at in those documents, but we're only focusing on the global warming potential in this project. So the trick with EPD is that they calculate a value per unit of product. So that's the main reason they're hard to compare. Each EPD might use a different unit, so we might be talking about kilos or meters. In this example, the EPD gives you a global warming potential for 1 unit of WC, but that unit is 1 kilo of WC. But the WC itself doesn't weigh 1 kilo, it probably weighs about 15 kilos. So there's this extra step to calculate how much your WC actually emits. and that usually isn't included in EPD, so that's up to the reader to calculate it. So in this project, I focused on the FF&E that's specified by the architect. So this is equipment where we have a say in what's going in the building. So the goal was to find EPDs for that FF&E and to use Revit families and schedules to then calculate this last step automatically in Revit. So you can see here, using Revit families, I had an extensive existing Revit families library. So I used shared parameters to include the data that I gathered from EPDs, and using calculated parameters, I could automatically calculate the global warming potential that's generated for each item, and also the totals over the entire Revit model. So I tested this, this workflow in an exemplar project. I work primarily in healthcare, so I tested it on a typical hospital ward of 26 bedrooms. In this project, there were 1,325 FF&E items, so less than there would be in reality, but it was a good representation of what you would expect. It was challenging in some cases to find adequate EPDs, especially for specialized equipment. So in some cases, generic data was used. In parallel, I used one-click LCA to do a conceptual LCA of the structure to have something to compare it with. So this diagram on the right, which kind of resembles the one that we saw previously, shows the very high embodied carbon of the structure and envelope in blue at year 0, so construction stage, and a smaller amount of FF&E in red, and I've accounted for a number of renovations over 60 years. Sorry, I don't know what's happening. So these diagrams break down those results. So on the first diagram on the left is only construction stage, so year 0, and there the structure and envelope in blue represents 73% of the carbon footprint of the building. But when you look at its operation and maintenance phase, so year 1 to 60, actually with all those renovations, FF&E represents 63% of the carbon footprint over that period of time. So in total, when you include construction and the years of use, the FF&E in red here represents 42% of the carbon footprint overall, which is quite significant. So on a side note, as I said, I've only focused on FF&E that's specified by the architect, but in all projects there's a proportion that's specified by the client themselves. So they're shown in green here. The carbon footprint of those items would add up to the FF&E that's specified by the architect. So actually the carbon footprint overall of FF&E would be higher. Of course, the architects have a level of implication in choosing those FF&E with the client. We can provide recommendations to help them choose better products. So just in conclusion, we can see that FF&E has a significant impact on a building's carbon footprint over its lifetime, and it's worth looking at it. This workflow provides indicative values of the carbon footprint generated by FF&E from the early design stages. If you use it in combination with an LCA tool for the structure and envelope, the information collected is very valuable. So there are limitations on this workflow. EPDs are still in infancy, they're quite hard to read and hard to compare, and they're not available for everything that we might include in a project, so in some cases there is no data. In addition to that, when you look at an EPD, the values given need to be compared to something else. There's no way of knowing if your product is good or bad just from looking at it when you're selecting it. Another key challenge here is the life expectancy of your building. We use 60 years in calculations, but in reality, most buildings are kept in use for much longer than 60 years. So if you look at this diagram there on the right, really we can expect a building to be used 100 years, 120 years, and during that time there will be more refurbishments, either to bring the building to modern standards or for change of uses or things like that. And even if you account for some structural work that will probably be needed, we can expect the FF&E to have a very high carbon footprint by the end of use of the building. So just to finish, this workflow really would need to be tested on a real project now and ran in parallel with a structural LCA to have comparison, and ideally run it again once the project is completed to be able to compare it. So this workflow is best suited to projects that have a very high level of repetition of rooms. It's much easier then to gather the EPDs. So I specialize in healthcare, so in hospitals you can imagine recovery wards, bedrooms, en-suites and clinical rooms are repeated a lot across a project, whereas it would be more difficult, for example, in restaurants and shops, where in each project you'll have new products, so every time you would probably have to look at new EPDs. So although the workflow works in Revit, it would be more user-friendly and easier to manage several projects with a Revit plugin, which could be the next stage now of this project. So that's me done. Thank you very much for your attention. If you have any questions, I'll be happy to.